So here are 2.9 day 2 notes. Once again, we are modeling with polynomial functions. So we're going to go off of what we did yesterday on the 2.9 day 1 notes when we talked about finite differences. So yesterday we talked about finite differences and how it tells us if we are able to use the table to model a polynomial function and then figure out the degree of that polynomial. So once again, we're going to do the same thing, but now we're actually going to find that equation using matrices. We will also use regression to find a model as well. So let's get into our example 1. So we're going to use finite differences and a system of equations to find a polynomial that fits the data. So the first thing is we have to figure out what order difference this table represents. So our first thing is we need to figure out the differences from our two values here. So on these first two, remember what we do is we take the previous number and subtract it from our first. So here we do -2 minus 20. That should give us -22. Then we do the same thing for the next. We do -4 minus a -2. That gives us -2. Then we do 2 minus a -4. That actually gives us a +6. Then we do 4 minus 2. That gives us 2. And then -10 minus 4. That will give us -14. Now notice here that our differences are not exactly the same. So now we need to subtract our differences here. So our next time we do -2 minus a -22. That gives us a 20. Then we do the next one, 6 minus a -2, that gives us 8. Then we do 2 minus 6 to give us -4. And then -14 minus 2, which gives us -16. Okay, once again, these values are not constant, so we need to find the differences of these differences. So we do 8 minus 20, that gives us -12. Then we do -4 minus 8, that gives us also a -12. And then 16 minus a -4, that also gives us -12. So now our differences are constant, and this will allow us to figure out which degree difference this is going to be. So remember, to find that out, we just count the rows. So this first type of difference, the red, that was 1. The green was 2. This blue was 3. So this is what we call a third order difference. So that means our degree for our polynomial to represent this model or this data is going to be 3. So we're going to have a cubic function. So our degree is going to be 3. So we're going to have a cubic function. So now we did our first part of using finite differences. Now we have to write a system of equations to find this cubic function here. Now the general form for a cubic is as so. It is y equals ax cubed plus bx squared plus cx plus d. And what we have to do here is we have to find the values for a, b, c, and d. To find these values, we are going to use matrices. So we've done this before in our quadratics unit when we have to create a system of equations, plug it into our matrices, which will give us our coefficients. Now notice how many coefficients we have to find. We have to find 4 values. That means we have to create 4 equations. Now to find these equations or write them out, we will have to use the points from our table. And we're going to use the first 4 points from our table. So this will allow us to create 4 equations. Now make sure you notice which ones are your x and which ones your y values. Okay, let's go ahead and write it out. So we have x and y. I'm going to list out all the points that we are using. So our first point going back up to the table is 120. So that's going to be our first one. Then we'll have our second point to be 2, -2. Then we'll have 3, -4, and then 4, 2. Okay, so now what we're going to do is we're going to plug these points for every place we see x and y. So on the first one, 120, notice that 20 is our y value. So we're going to plug it in for y. So we have 20 equals. Now a, we keep that as a because that's basically the coefficient we're trying to find. So we have a times 1 to the third. Oops. There we go. Plus b times 1 to the second power, then plus c times 1, and then you got plus d. So now let's go ahead. We are going to simplify this just a little bit more. So we have 20 equals. So first we evaluate 1 to the third power. Well, that just gives us 1. So that means we have a, or 1a if you want. Well, 1 to the second power is just 1 as well, so we have plus b, or you can say 1b. Then c times 1 just gives us c, and then we have plus d at the end. Now we're going to do the same thing for each of these points. We plug in our y into y, and then plug in our x into each x spot. So on the second one, we have -2 as our y value. Then we have a times 2 to the third, then plus b times 2 to the second, plus c times 2, and then plus d. Then simplifying this, we still have -2 as our y value equals. Now we do evaluate 2 to the third power. That gives us 8. So we actually have 8a. Then we evaluate 2 squared. That gives us 4. So we have plus 4b. Then c times 2 gives us plus 2c. And then once again, we just have a d at the end. Okay, on our next one, 3, -4. -4 is our y value, and then we plug 3 into x. We have a times 3 to the third, plus b times 3 to the second power, then plus c times 3, then a plus d at the end. To simplify this, we have -4. Now we evaluate 3 cubed, and that should give us 27, so we have 27a. Then we do 3 squared, that gives us 9, so we have plus 9b. Then c times 3 just gives us plus 3c, and then a plus d at the end. And then our last one, 2 is going to be our y value, and we plug in 4 into x. We have a times 4 to the third, then plus b times 4 to the second, plus c times 4, then plus d. And then to simplify this, we still have 2. Now we do 4 to the third. That's actually going to give us 64, so we have 64a. Then 4 squared gives us 8, so we have plus 8b. And we have 4 times c to give us plus 4c. And then we got plus d at the end. Now, using the blue simplified versions of our equations, we're going to create our matrices. Now remember, when we do our matrices, we have our A matrix, which basically are the coefficients in front of our A, B, C, and D. Then our X represents the variables, and then our B is basically the constants or the Y values. So make sure you get this all down on your notes. Remember, if I'm going too fast, just pause the video so you can get everything down. Okay, now I gotta make sure I get room for myself. So we have the A matrix. So I'm going off of the equations that we have. There we go. From the beginning here, or on the blue, for our A. So starting from the very top, we have 1, 1, 1, 1, because that's basically the coefficients on our A, B, C, and D. Then next we have 8, 4, 2, and 1. Then for our third equation, we have 27, 9, 3, and 1. And then for our last one, we have 64, 8, 4, and 1. Okay, now we multiply that by our variable matrix, which is going to be our X matrix. And our variables here that we're trying to find are basically A, B, C, and D. And then we set that equal to our B matrix, which this basically consists of the constants. So the constants we had from beginning, and we start from our very first, we have 20, -2, -4, and 2. And remember, we write that in a vertical column there. So now that we have this, writing our matrix equation, we'll have AX equals B. And remember, so we can solve for X, we move A over. When we move the A over, it actually makes it an inverse. And we will take our A inverse and multiply it by our B matrix. Okay, so let's go ahead. We're going to plug this all into our graphing calculator so we can get our values for the X matrix. So this is where we do need to use that. Okay, so remember to go here, what we're going to go to is our second, and then it's going to be the inverse key, x to the negative first, or if you see in blue it says matrix, that's what we need to go to. Okay, so the first thing is we edit our matrices. Now notice when we edit here, we need to make sure that we have the correct dimensions. So we go back to our A matrix, notice how many rows we have. So we have 4 rows and we have 4 columns. So this really is basically our dimension of A is a 4 by 4. So we're going to put 4, enter 4, and then plug in those values. So we basically have 1, 1, 1, and 1. Then our second row, we have 8, 4, 2, and 1. Then our next one, we have 27, 9, 3, and 1. And then our last one, we have 64, 16, 4, and 1. There we go. Good. Now I just noticed on mine, I put 8 instead of 16. So make sure on your notes you kind of correct this mistake that I put here. So I just noticed that, well, 4 squared is not 8, 16. There we go. So make sure on that fourth equation, instead of making an 8b, you change it to 16b, and that this right here is going to be 16. But everything else should be correct by here. Okay, so we have done our A matrix. Now we're going to do our B matrix. Once again, make sure you know the dimensions. Notice how many rows we have. We have 4 in just one column. Remember, to find the dimensions, we do rows by columns. So this is a 4 by 1. So once again, I go to second matrix, and then I go over to edit, and I want to edit my B matrix. This is going to be a 4 by 1. And now I'm going to enter my 20, my -2, my -4, and my 2. Now, once I've done that, I got to go back to the main screen. To do that, we do second mode. And then once again, we go to second matrix. We do A, we press enter. Now remember, we want the inverse of that, so press the inverse key. Then once again, we go to second matrix, and then go down to B. From here, we press enter. And then here are values we get. We get -2, 22, -74, and +74. So I'm going to write those out. Now, we're not done, because what we have to do is write a polynomial function. So we're going to take these values, and now these are A, B, and C, and D values, and we're going to write a cubic polynomial function. So our final answer is going to be y equals -2 x to the third, then plus 22 x squared minus 74x plus 74. And then this would be our final answer. So make sure once you've gotten your coefficients that you plug it back in to write your polynomial function. Okay, let's get into our second one. Once again, we are going to use our graphing calculator to do that. So here, for example 2, it says the data in the table gives the average speed y in knots of the Trident motor yacht for several different engine speeds. For part A, what we have to do is write a cubic regression. So last unit, for our quadratics unit, we did quadratic regressions. So in this case, we're going to do a lot of similar things, but now instead of having quadratic, we will have to have a regression. So the first thing we need to do is plug these table of values into our stat, or L1 and L2. Now remember, L1 represents our x values and L2 represents our y values. Okay, let's go ahead and do that. So go to the stat key and we want to edit. So here, remember, if you want to get rid of like some values you have here, you can press clear and enter. And you want to make sure that your L1 or L2 is highlighted when you do that. So our x values here are 9, 11, 13, 15, 17, 19, and 21.5. Now, all you have to do so these values get into here is press enter after each value. So now I do the same thing, L2, I make sure I highlight it, press clear and enter, and it clears that list. Now we're going to do the boat speed. So our first one, we have 6.43, then 7.61, 8.82, 9.86, 10.88, 12.36, and 15.24. And make sure these line up, because otherwise you're going to get an error if they don't. Okay, so now what we're going to do, once again, we're going to press stat, and we're going to go over to calc. So now what we're going to do is our cubic regression. So what we're going to do is actually go to number 6, because this says cubic reg. That's what we're wanting. So I'm going to press number 6. And you should already have where it says X list is your L1, Y list is your L2. If that's all good to go ahead and go all the way down to calculate and press enter. Okay, so here we have our A, B, C, and D values. So we take these and plug it into those variables there. So let's go ahead, we're going to write that down. So we have, don't forget your y equals, because we need to make sure this is a function or a model. We got y equals 0.0048 x cubed. Then we have minus 0.194 x squared plus 3.13 2x, and then minus 9.530. That'll be our constant there. Okay, so that is our quadratic regression model for the given data. So now part B, it says, estimate the average speed if engine speed is 2,400 RPMs. So here, if we go back up, right, it says that our x values, which is in hundreds of revolutions per minute, okay, and that our y values are in knots. So what we're going to do for the x, since it's in hundreds of revolutions, is we are going to have our x equal to 24. So we don't really need the zeros in there because we already know it's in hundreds. So our x value is going to be 24, and since we're trying to estimate the average speed, which is at our y value, we're going to take 24 and plug it into each x that we see. That will allow us to get us our y value. So if you need to show work, all you really need to do is just show that you plugged in 24, or whatever your x value, into the function. So I plug 24 for every single x that I see. And then really all you have to do is plug this into your calculator, which we'll go ahead and do that. And then just plug all of it into your calculator, really, so it just makes it a lot easier. So here, what we have is we have our 0.0048, and then plug in 24 to the third power. Then we subtract it from 0.194 times 24 to the second power. Then plus 3.132 times 24. And then we'll subtract it. So minus 9.530, which you don't really need to put the 0 at the end for that. And so here we get about 20.2492 knots. Okay. So here, let's go ahead. We'll just round to 3 decimal places. So 20.249. So our answer here, and I'll put it in blue to kind of, so we said 20 point, and you go back to 2.249. And because this is a real world problem, please do not forget your labels, okay? So in this case, if we go back up to figure out what is our y in labels, they said that's in knots, okay? So that's where we're going to put it. So all you have to do is just write the word out, knots. There we go. And that would be your answer there. Okay. Now our last one for part C says, what engine speed produces a boat speed of 14 knots? So notice here that the 14 knots, right, our boat speed, that's our y value. So that means for this problem for part C, we are trying to find the x. So you're given a y value, but you need to find the x value. So So this kind of corresponds to what we have done before to find our x values. So what we're going to do is we're going to take that 14, right, and we've done this before. It was our 2.4 graphing calculator section. We're going to take 14, plug that in for y, and set it equal to our function here. And then from here, you do have options. You can either move the 14 over by subtracting it, and then just figure out what the x-intercept is, the appropriate one, because this is a real-world application. Or, like we did for the 2.2 or 2.4 graphing calculator, we could just set our function equal to y1 and then the 14 to y2, and then figure out where they intersect. So both ways would be correct. What I'm going to do is kind of just use my 14 as my y2, and then use this function here, what we got for our quadratic regression, as our y1. So what I need to do is I'm going to plug this into my graphing calculator. So I need to go to y equals, clear anything I have here. So my first one, I put 0.0048 x cubed. Then we have 0.194 x squared. Then plus 3.132 x, and then minus 9.53. And then my y2 is going to be 14. So let's go ahead, we're going to graph it. I'm going to go back to our z standard just to see if we can see that. Okay, so it looks like we can't see, and this does make sense because notice that our y value here, right, our y2 is 14. So we really need our max to be at least 14 so we can see where it intersects. So we're going to go ahead, I'm going to make my window a little bit bigger on the max side here. I'm going to go ahead and go 15. And then I'm going to go by 5s. And then see if I'm able to see the intersection point. Okay, I see that intersection point, so that's good. So now what I'm going to do is I'm going to press my second trace, and I'm going to go to number 5, intersect. Now, if you move the 14 over, then you're going to do a completely different keystrokes. So if you subtracted the 14 over and only just did a y1, then what you're going to do is actually go to number 2 to find your 0, or find the x-intercept, okay? So if you're doing what I'm doing, we're going to find the intersection. So we're going to do number 5. So remember, to figure this out, I always just say bring your cursor as close as possible to the intersection point. So then that might help a little bit. So we do that, so we press enter, we press enter again, and then remember, press enter for one more time. And then here we get our x equals 5.709. So that's where those two intersect there. Okay. So now we have our x value, and that'll give us our answer here of what the engine speed produces, or speed produces a boat speed of 14 knots. There we go. Now we also need to make sure we go back to the units, right? What engine speed produces that. So we look here, it says that our different engine speeds x is in hundreds of revolutions, okay? So though we got x equals, and I gotta go back there, though we got x equals, whoops, I lost it. Okay, I'm gonna just go back and do that again. There we go. So we get 5.7. We'll kind of just round to, let's do 3 decimals as we've done before. So 5.709. Okay. So that we got this, we do need to multiply basically by 100 because it was in hundreds, right? So that means we move the decimal over twice. So we get about 570.9 RPMs. And this will be our final answer here. So if you have any questions, make sure you come in to see me either before or after school, or you can always email me. And don't forget your homework is on Schoology. And then the filled in notes, if you rather look at that, those are also on Schoology.